In this video, we're going to learn about transformations of functions. First of all, we need to know about functional notation. Functional notation is basically a way of showing an input and an output. You can think about it like a number machine. Inside the brackets, the x, this is the input to our number machine. We also call it an argument. And then what we end up with is f of x. That's how I read this, f of x, not fx. It's much easier when we see an example. For example, if f of x is equal to 3x squared, if I want to calculate f of 0, all I need to do is substitute 0 into the expression 3x squared. So I would have 3 times 0 squared, which is just 3 times 0, which is 0. So I could say f of 0 is 0. F of 1 is going to be what I get when I substitute 1 into the expression, which will give me 3 times 1 squared, 3 times 1, which is 3. F of 1 plus 2, we need to think with our BIDMAS head on. We need to work out what is inside the bracket first. So f of 1 plus 2 is f of 1 add 2, which is 3. So to work this out, I need to do 3 times 3 squared, which is going to be 27. However, D looks similar, but because we have f of 1 and then separately plus 2, we need to first work out f of 1, which is 3 times 1 squared, and then add 2 on the end, which will give you 3 plus 2, which is 5. So just notice, when I have f of 1, I get 3, but then if I have f of 1 with a 2 added on the end, I get 5. So we can see it's basically just added 2 on as we would expect. First of all, the first transformation of function I want to look at is called translation. We've seen translating in basic terms, but this is how we represent it with an equation. F of x to f of x plus a outside the bracket means a translation by the vector 0, a. All that means is we shift the graph up, the graph of f of x up by a units. For example, the graph of f of x is shown. Sketch the graph of y equals f of x plus 2 on the same axes. And then sketch also the graph of f of x minus 2. This is the graph of y equals f of x in blue. If I want to sketch the graph of y equals f of x plus 2, the entire graph will shift up by 2 units. So we can see here it's got this lowest point at 0, 0. Well, for the new graph, f of x plus 2, that lowest point is going to be at 0, 2. And similarly, for all of the y coordinates, they're all going to go up by 2. So, this 2, 4 point is going to become 2, 6. Minus 2, 4 will become minus 2, 6, and so on. And then we just join up those points. So, trying to be somewhat neat. And that will be the graph. The shape of the graph hasn't changed, although it's hard to see from the diagram. But you've just moved it up. It's like you've literally pulled the graph up by 2 units. Similarly, f of x minus 2 will mean shifting the graph down by 2 units. So again, we don't want to change the shape of the graph, but we want to notice that it will be shifted down by 2 units. I've done a slightly neater sketch here, or neater picture here. We can see this is f of x plus 2, and then the one which is shifted down by 2 units is f of x minus 2. The transformation of f of x to f of, so the brackets, now what's in the brackets has changed, f of x plus a, means a translation by the vector minus a, 0. Now remember, the top number in a column vector represents the x and the bottom represents the y. So all this means is shifting the graph to the left by a units. It doesn't behave as you expect. You'd think this would move the graph to the right, it moves it to the left. So if I have f of x plus a, so it will move the graph a units to the left, and similarly, if I have f of x minus a, it would move the graph a units to the right. Again, we're not changing the shape of the graph, we're just moving it. So in this example, we have the graph of y equals f of x. We want to sketch the graph of y equals f of x plus 2. Now what that will do, it will move the entire graph to the left 2 places. A good trick is to look at where the graph has a minimum or a maximum point, so here that's at 0, 0, and to move that first as a bit of a guideline. And then we can draw the graph again. So we can see 2, so it should go to the y-axis here. We can see that it goes through 2, 4. If we shift that to the left by 2 places, it will go to the y-axis there. So we can see that it should go to here. So from 0, it's going 2 to the left. It should look like that. And then the graph of y equals f of x minus 2, or f of x minus 2, this will shift the graph to the right by 2 places. So this time it will look like this. Again, the minimum point is being moved 2 places to the right. Apologies for my sketch there. So it will look something like that. So this should be y equals f of x minus 2, and this one is y equals f of x plus 2. Again, a slightly neater picture of the situation is here. We can see f of x plus 2 is moved 2 places to the left in red. F of x minus 2 moved 2 places to the right in grey. Now let's have a look at some scale factor transformations before we do some example questions, before you do some practice questions even. If I write y equals f of x, and then I have f of x being transformed to k times f of x, this will be a stretch by scale factor k parallel to the y-axis. All this means is we times all the y coordinates by k. So here we have again the graph of y equals f of x. We want to sketch in the axis y equals 2f of x. All of the y coordinates will be multiplied by 2. So again, if I look at the y coordinate here, so that's at the maximum point, it is 4. So for 2f of x, the y coordinate will be 8, but the x coordinate will be unchanged. At minus 2, 0, the y coordinate is 0, so that means it doesn't actually move, nor does the y coordinate move at plus 2. So we know the graph, the new graph, will go through those coordinates again, but all of the other y coordinates will be multiplied by 2, or will have visibly changed. So the finished graph should look something like that. It's just important that you show it going through the x-axis and that the maximum point has been multiplied by 2 in the y-coordinate. Again, a slightly neater graph would be here. The transformed graph is in red. As before, when we have a transformation inside the bracket, it doesn't behave as we expect. So here's the graph of y equals f of x. If I want to sketch the graph of y equals f of 3x, we actually divide all of the y coordinate, not all of the y coordinates, all of the x coordinates, sorry, by 3. More formally, if I'm going from f of x, that should be f of x, to f of kx, sorry, it's a stretch of scale factor 1 over k parallel to the x-axis. So we divide all the x coordinates by k. So here we have f of 3x, so we divide all of the x coordinates by 3. Again, a good rule of thumb here is to look at where it goes to the x-axis. So it goes to the x-axis at 3, 0 and minus 3, 0. If I divide 3 by 3, I get 1, and minus 3 divided by 3 is minus 1. At the turning point, or the maximum point, the x-coordinate is 0. 0 divided by 3 is still 0, so that's going to be unchanged. So we can see that the graph will look something like this. As you can see, it's had the effect of squashing the graph, if you like, but it's still called a stretch. The transformed graph is in blue in the neater diagram. Finally, we come to reflections. If I have y equals f of x, and I transform to y equals minus f of x, this is a reflection in the y direction. But we can consider this as just minus 1 times f of x. So essentially, we multiply all of the y coordinates by -1, and you reflect the graph in the x-axis, which is in the y direction. Here's the graph of y equals f of x. On the same axis, we want to sketch the graph of y equals minus f of x. To do this, all of the y coordinates will be multiplied by -1. So instead of, well, -3, is not going to go anywhere because 0 times anything is still 0. -110, however, will go to -1 minus 10. The x coordinate is unchanged, so that will be down here because I want to indicate very clearly the turning point coordinates. Turning points are just maximum or minimum points. 0, 8 will go to 0, -8. 2, 0 is unchanged. 3.5 minus 1.5 will go to 3.5, 1.5. It's only a sketch, but I want to try and be neat. And all of the points where it crosses the x-axis are going to be the same because they have y-coordinate 0. So the graph will basically look exactly like the graph we originally have, but it's just reflected, so it's basically turned upside down, it's reflected in the x-axis, or we can say in the y direction. So I'll do that. Smoothly go up there, and then down like that. So more neatly, your finished graph will look like that. That's the transformed graph y equals minus f of x. And finally, y equals f of minus x is exactly the same thing, but it's a reflection in the x direction. We multiply all of the x coordinates by -1. So if we have the same graph as before, y equals f of x, if I want to sketch y equals f of minus x, it will be the same graph, but we multiply all the x coordinates by -1, leaving you with this transformed graph. The hardest question at GCSE that you could get would be a combined transformation. Here's an example. We are given the graph of y equals f of x. We want to sketch the graph of y equals -2 f of x plus 1. What I'm going to do is transform from the inside out. I'm going to transform in the brackets first and then work out. So first of all, let's consider the transformation f of x to f of x plus 1. That will translate our graph one place to the left, as we can see on the right. So now we look at the graph on the right and we need to multiply it by 2. If we do this, this will stretch the graph parallel to the y-axis by scale factor 2. It essentially multiplies all of the y coordinates by 2. Finally, to go from 2f of x plus 1 to -2f of x plus 1, we multiply all the y coordinates by -1. This will reflect the graph in the x-axis. So the final graph, y equals -2 f of x plus 1, is shown here. What we're going to do next is some practice questions. But if you're really interested in a really hard example, you can have a look at the example I'm going to do now. Otherwise, skip ahead to the questions. This is a really hard example, probably harder than what you would get at GCSE. You are shown the graph of y equals f of x, and what we want to do is translate it. Well, the graph is the same as the graph from before, so we've already done the translation 1 unit to the left, but now we need to multiply by 3 in the bracket. Now remember, that's going to have the effect of dividing all of the x coordinates by 3. Then what we would have to do is translate it, so, or not translate it, now we have minus in front of the 3x, so we need to reflect it in the x direction, or the y-axis. And then finally, we have the -2 on the outside, so we need to stretch it by 2, and then reflect it in the x-axis, giving you a final graph which will look like that. Here is a question for you to try. Please sketch this on squared paper so you can have a go at it. The graph of y equals f of x has been sketched. Give the coordinates to the turning points of the graph y equals 3 f of x plus 1. Here is the answer. The maximum for your new graph should be at -4, 15, and the minimum should be at 0, -3.